Okay. All right, now let's just move on. Okay, now we get to so far we've worked with strings and numbers. Well, it's all fun and games, but it gets kind of boring after a while. Now let's get to the fun part of programming, one of the main concepts in functional programming, which is called function. Now let's look at something that I will let you know that happens to be a function, but just let's try to understand it by staring at this piece of code a little bit. So let's just look at here. Okay, so what can we recognize from before looking at this piece of code? So we do recognize let, yeah, that's a keyword that says I'm defining something. And we do recognize what comes after that is just a name for a variable. We said, actually this is should be blah. Okay. So we do recognize a name. We're giving it the name blah. That's fine. The type declaration colon something is missing. Okay, that's interesting. And then equals, yeah, we do recognize that before. This is when we assign some value to a variable, an expression. And then we have an open and close curly and then some pieces of code inside it. So this is a sign that we're defining what is called a function. Now what happens inside is you see some, again, we do see a variable declaration. It's called n and its type is int, but it's inside this parenthesis. It's kind of interesting. And then we have this dash greater than sign, which is like an arrow, and then we have this arrow, and then we have another type, and then we have a keyword that's called in. Okay, it's all interesting. And then we have on the next line we have something called return, which is also a keyword, as you see is highlighted here. And then we have 2 times n. Now and then on the next line what I have is print. I recognized print before. It prints whatever the value of whatever expression that you give it inside the parentheses. But the expression that we give it is kind of interesting. It's a name which we recognized before because we defined it on top above, and then inside the parentheses a number 13 here. Okay, so I don't quite know what all this is doing, but if I copy this and run it in my interpreter, I get some lines here, the kind of mumbo jumbo, but on top, after the print, I get 26. So can you guess what all this has done? That's right, it seems like it just multiplied 13 by 2. Now, where in this program said multiplied 2 by 13? Well, the only place I recognize some multiply happening is this line, 2 times n. So what's happening, it seems like what's happening is it assumes when it gets to here that n is 13, as if inside it was doing something like this, and then it computed 2 times n. Yeah, sure enough, if I had done this declaration and then I said 2 times n, I would get the value, I'm sorry, this is 13, so I get the value 26. Okay, so this is called, on top is called a function. And a function has a type of itself, and this whole thing on that I'm highlighted here is the type of a function. And a function has an input type as well as an output type. In this case, the input type is inside the parentheses on the left of the arrow. So this is the input type. Okay, an input type of this function is of type integer, and we have given it a name n, and then the output type of the function is also integer, int. Now, it doesn't have to be the same as the input. In this case, it happens to be the same. So what is this saying is, this is a function that takes an input, which we're giving it name int, n, and it has a type int. And as a result of this function, it's going to produce a value that has a type int. So that's the right of the arrow. And that value, what would it be, is defined by what comes next after this return keyword. It says take the input, which is n, multiply by 2, and then produce the result. And then where does that go? It goes wherever you actually go ahead and use the function. So in here, inside the print, is what's called calling a function or invoking a function. So in this case, we have defined the function on top, giving a name blah. And then here we are using that. We're saying call the function blah, assuming its input is 13. So it goes here and goes, okay, I'm going to have to run this function or invoke this function. But because the user has set 13, it means that I have to assume n, in this case its input, is 13. So it's going to come here and says, okay, return 2 times n, and n is 13, so it becomes 2 times 13. And go ahead and return that value back to whoever called you, in this case right here. So from here we get instead of blah 13, it's going to come back and says, okay, that returned the value 26 to me. So print says, okay, I'm getting print 26, and that's how we get a 26 here. Okay, so this all sounds a very kind of complicated process. And it's okay if it's a little bit confusing. Functions are actually maybe one of the most important things in programming. So it takes a while to kind of get the concept. This is what's called abstracting computation. So the reason with abstracting computation is that we're having a piece of code, which is a function, and we can use it not just one time, but many times. In different contexts. So notice that once I have defined blah, I can say print blah of 13, but also I can say print blah of 5. Interesting. What do you think that prints? That's right. It's just, if I just do this, it's just going to print 5 times 2, which is 10. So we have defined the function only once, but you can use it many times with different values. So this is abstracting a computation. You don't have to write it again. We've computed, we're just running the same code but with a different input, in this case 5. So all that kind of reminded me of an analogy, and which is the analogy of a juicer. So you can think about a function as a juicer machine. So what does a juicer do? Well, it takes some inputs, in this case produce vegetables and fruits, and here, so it takes them in and it does some work with them, in this case gets the nutrients out of them, gets rid of the pulp, and what it produces, something, it produces juice, right? So that's the output. So it takes an input, and it can take more than one input, and then does some work, and then here it produces the output. The output, there's always one output, there isn't multiple outputs. So there could be many inputs. You can put different kind of fruits and vegetables there, but then you get one output as a result, your juice in your cup. Okay, so think of functions as these juicers. You don't just throw a juicer out once you use it once. You can keep it because it still functions the same. It always does the same thing, juicing, right? But you can use it at different time. You can use it with different fruits and vegetables. So this is exactly what you can do with a function. Okay. Now that we know a little bit about types, if you think about what is the type of this function, well, we've seen that when you declare the type of the input for a function, you put it in a parentheses. So let's say we have this imaginary type. We only have seen integer and string types, but let's say there is a type called produce. Okay, so in this case, the type of input for this function is indeed produce, right? And the output type for the function juicer is, let's say, something called juice, right? So if we want to give a whole type for the whole function, is what you see on the bottom, which is inside the parentheses produce, arrow, and juice on the right side. So this is the type of the function, which is a juicer. Takes a produce and produce juice. Very well. Now let's go back to here. We're not quite maybe ready to understand the whole function definition here, because there's a lot of characters and funky letters and characters here. But we'll get it after a while with some more practice. Just keep in mind there's some letters that words that you see highlighted in purple here, let and in and return. These are what's called keywords in a language. So keywords are used to define, as part of the syntax of your program, your language, to kind of directives that tell the programming language what to do. So they're reserved words. You cannot call your variable, for example, let or return or in. Okay, so just remember, don't name something these names. Okay, so when you do define a function, you'll be using, for example, in this case, in. And how does that work? Well, when you define a function, start the open curly, and then we need to define the type of the input. In this case, give it a name, let's say n, and give it a type, put that inside the parentheses, and then the arrow, and then say what type of the output is. Well, because the input is integer, and this function does what? It says 2 times the input, right? So what is the type of the output? Well, still a number. In this case, the output will still be int. But remember, it doesn't have to be. Maybe a function takes a number and produces a string or something else, as we see later. Okay, and then finally we have this return in the second line, and then some expression. So what does this return do? Return is a keyword that says return the value that's computed from running this function, whatever comes in front of the return keyword, and give it back to whoever called this function. Just like the juicer says, okay, throw the result into the cup so that the user or whoever is using the juicer can drink the juice, right? So in this case, goes ahead and returns the value that it just got, multiplying the input, let's say 13 by 2, and returning 26 back to whoever would call it. In this case, it was called here. So as we saw, this whole function called blah with input 13 got the value 26. So it can basically simplify to this, and then print got the 26 and said, okay, I know how to print 26, and it did for us, right? And same with the other call. Now you might think, okay, so it seems like what's happening is inside of this function, when we're computing this value, n is going to be what is called bound or assigned a value that we give it inside when we call it. Like I said, is as if we have inside here, as if we saying let n equals n be an integer and be equal to 13 when we call it, and then we used it, right? So return 2 times n. But what's interesting is that when we're done with this function, n is no longer defined. It was only used inside this function when it was called. But if I go ahead and say print n here, where it says n, I don't know n, it's use of unresolved identifier n. So it's basically saying n is not defined. But n was defined when we were calling this function. So we'll get to this later, but just keep in mind that the variable that is called the argument or parameter for this function, n, is only going to be usable inside this function when we're defining it, inside these curlies, open and close. Once we're done with calling the function, it's gone because we just got the output. It's just like, you know, the juicer forgets what produce you give it to, right? The juicer just gave you the juice, so he forgot about everything that he just did. So it's the same thing here. But what happens, interestingly, if I do define n, let's say if I say n is 17, it says okay, n is 17. Now if I say print blah of 13 again, do you think n is going to be 17 when it's using that here, 2 times n, or is it going to be 13 as we call in the function with that value? Well, you guessed it right. It's going to actually still give you 26. This decoration on top doesn't affect it, and that's what's called shadowing. It's an advanced topic. We don't have to worry about it, but if n happens to be defined outside of this function, but when you get into this function, because n happens to be a parameter or argument for this, locally within this function, this is going to take precedence. So it says, okay, you tell me n is 13 here, I'm going to ignore that value before that it had. Okay, so we'll get to this topic later, just in case you were wondering about that. I mentioned that. Otherwise, you don't have to worry about that. All right, so now that we kind of know what this function does, it seems like it's just doubling the input, right? Whatever you give it, it gives double. Why not give it a better name? Okay, yeah, that would be a good name for it, right? So we just call it double because that's what it does. Now, I have a question. So what happens if I say print double Joe? Do you think it's going to be happy with that? Well, I don't know. Let's try it. Let's define print. Define that function double. And never mind this extra line that kind of prints here. This is just how it represents a function definition. But it's happy with double. Now, if I say print double Joe, what do you think happens? Well, it says error. It's a type error because it says cannot convert value of type string to expected argument type int. Interesting. So that's kind of a descriptive error this time. Kind of understand it. What it's saying, double, when you define it, you said it's going to take as input an integer. But what you give it is what? Is a string. I don't know how to use a string as an integer. So you can't run this function like this. So it basically is a type error again. We get a type checking error. I mean, it makes sense. So again, function is very important. When you call a function, you call it with the right, what's called arguments or values, so that they have the right types. The types need to match. Okay? Now, let's move on. Now, functions, as we defined them before, are so common in programming, in any kind of programming, that in this language there's a different way that to define them. Maybe a little shorter, maybe not. But here's how you define them commonly. So normally people don't define functions like this, what we did. That's kind of the longhand. The shorter way to do this, maybe not so shorter, is using a keyword called func. So we start, which is short for function. So you say func, just like let is saying I'm defining something, but in this case you're specifically saying I'm defining a function. And then we give it a name, or we use the same name double as before. And then instead of doing equals curly, we give the type of the function. So as I said, this whole thing is a type of a function. It's a name of a variable, and then the type of the input variable, and then the arrow, and then the output type. Now, is the same as before, so this is like actually like was this before, right? N, not number. But there is one extra thing. So that then we have curly as we see before, and then we don't have the in that we had before, and then we had the same body of the function, which was return 2 times n. Okay, so basically this is define the same function. And if I go ahead and run it as before, so say print double 10, well, it should just do what we expect, which is double 10 and prints 20 for us. Very well. Now there's a little funky little underscore here that we hadn't seen before. And what is that? Oh, I can take it out and probably it would be okay. Let's see.